Alright, so Chapter 22, Wide Area Network Connections. This covers basically a 10,000 foot view of WANs. It doesn't go terribly in depth because you can spend a whole career learning just a particular type of WAN technology. This is just to kind of give you the basic overview of that. So for WAN connection types, and we'll go over each of these individually, you've got leased lines, circuit switch networks, packet switch networks, broadband, virtual private networks or VPN, and metropolitan Ethernet. The CCNA exam is going to focus primarily on leased lines and frame relay, especially frame relay. The whole next chapter is going to be exclusively frame relay and configuration. So leased lines provide a dedicated point-to-point link between two locations. If you have a T1, a full T1 speed of 1.544 megabits per second, you always have that amount of bandwidth available in both directions, even if you're not using it. It's always there. It's always available. That's why it's dedicated. Lease lines are frequently required for VoIP between sites. So that's one of the additional costs of I guess setting that up. They are typically the most expensive type of line, and the cost is directly affected by, one, the geographic location, or geographic distance rather, between your sites. So if you've got two sites in the same city, and a dedicated line, a lease line running between them, it's probably not going to cost as much as a lease line running directly between two cities on the east and the west coast of the United States. The amount of dedicated bandwidth required is also the other factor that directly impacts the cost. So the more bandwidth, obviously, the more they're going to charge you for that. You also have circuit switch networks. Circuit switch networks establish a dedicated channel for the duration of the transmission and tears down the channel once the transmission is complete. It's also known as dial-on-demand or a connection-oriented network type. The PSTN, or the public switch telephone network, is a perfect example of this. If you need to make a phone call, the line is not open until you pick it up off the receiver, and it creates dial tone, and you dial your numbers, and when you're done, either you or the other person hangs up, and it breaks down that connection. So it's only there whenever you're using it. These frequently have a per use or per minute charge, as is in the case with ISDN. You also have packet switch networks. They enable a service provider to offer a large pool of bandwidth to multiple customers. The benefit to the customer is that they can typically obtain much more bandwidth for less money than a dedicated line. The negative aspect, though, is for the customer anyway, is that the bandwidth is not guaranteed, and their packets could be dropped during periods of high network utilization. These networks are typically set up using permanent virtual circuits or PVCs. So basically what the service provider is doing is, whatever kind of speed they're able to get to each of the individual homes or businesses that they're selling the service to is probably going to be the maximum that they'll offer it to you at. But because they're connecting so many users, the main trunk lines that connect all those users are probably not going to be able to support the full bandwidth if every single one of those users is using their full bandwidth at one time. So you don't have a guarantee of bandwidth. You most likely are going to get a lot of bandwidth most of the time, but there's no guarantee that you're going to get any set number of bandwidth. So if you're trying to run VoIP or something like that, for instance, you're going to need, if it's unencrypted or unencoded, 64K of bandwidth. You don't have any guarantee that you're going to get that, so you can't guarantee that calls are going to work or not work at any given time. And then broadband, which kind of falls into the same category. Broadband allows multiple signals to be sent over a signal at one time, as opposed to baseband, which only allows one signal at a time. Broadband consists primarily of DSL and cable services, which may allow for internet, video, and voice simultaneously. So like DSL, for instance, you've got different sets of frequencies that correspond to each of the services. So regular telephone service is going to use those lower frequency bands. You got the higher frequency bands, which are going to be taken over by your DSL connection. And then cable services are starting to do the same thing too, where they offer internet, video, and voice all over there using different frequencies. And virtual private networks, VPN, which will the last chapter of the book will get into this a little more extensively. They're not true WAN connections, but rather allow companies to use different types of WAN connections to connect to their internal networks across sites. So this is generally much cheaper than purchasing dedicated lines to run between every site. Virtual tunnels are encrypted and established to create a full mesh network between all sites. So, for VPN, again, it's not a true WAN connection. Usually you purchase some type of WAN connection, whether it's a dedicated line or cable internet, DSL, whatever, and then each of your individual users will build a tunnel that either connects to a concentrator or some other device so that they can all enjoy the VPN, the private network for your company over that public WAN connection. Metropolitan Ethernet uses fiber optic cable to provide connections with a very high bandwidth to locations in the same geographic area. I say in the same geographic area because that was probably the case about the time the book was initially written or started to be written. Now we've got fiber optics running clear across the country and even between continents. Fiber optic connections traversing much greater distances within a country and between nations have become very popular, following an evolution of Metro Ethernet that started at the beginning of this century. So that's the different types of WAN connections, at least from a very general perspective. So we move on now to the WAN, the physical layer. The physical connections for WAN are very diverse. The channel service unit, data service unit, or CSU/DSU is described as the box that connects and converts the WAN connection to another cable standard. This is an old definition, in my opinion, as many routers today terminate the WAN connection directly on different types of WIGs. So for instance, if you had a dedicated line, in this example, you've got your service provider, you've got your T1 line coming in right here, you got that T1 terminating on the CSU/DSU, and then the CSU/DSU subsequently changes the cable type over and connects directly to your Cisco router. What happens most of the time now is that the CSU/DSU and the Cisco router are combined into one unit, or at least the CSU/DSU will be a card that you can swap, a WIC that you can swap in and out of the Cisco router, so that it basically terminates directly on your equipment rather than having to have this additional piece of equipment that could be another point of failure. WAN data link encapsulation, layer 2. Once the WAN cable is physically connected, layer 2 comes into play. The data link layer for WAN connection also has a wide variety of options, as WANs have a wide variety of types. As long as the encapsulation is supported by your equipment and the encapsulation is set the same on both ends, the connection will work. If you purchase a frame relay connection, your encapsulation must be set to frame relay. If you purchase an ATM WAN, you must use layer 2 ATM encapsulation, etc. If you purchase a point-to-point T1, you have the option of Cisco HDLC, SLIP, or PPP encapsulation. Cisco HDLC is and I think we'll actually go into this a little bit deeper, but is basically HDLC was an open standard, but Cisco made some changes to that to make it a little bit better, and at which point it became a proprietary Cisco standard. So if you're using Cisco HDLC as the encapsulation between two of your locations, it has to be Cisco equipment on both sides. Most of the time you're probably going to be use PPP encapsulation if you've got different equipment or different equipment manufacturers on both ends. SLIP we're going to talk about, but it's not really used very frequently anymore because PPP offers a lot more benefit. So WAN encapsulation types, you got your serial line and internet protocol, SLIP, your point-to-point protocol or PPP, your Cisco high-level data link control or HDLC, X.25 link access procedure balance or LAPB, LAP, frame relay, asynchronous transfer mode or ATM, and PPP over Ethernet, PPPoE, and PPP over ATM, PPPoA. So I just actually mentioned this. Cisco HDLC. HDL was originally created by the International Organization for Standards, the ISO. Cisco later modified HDLC to support multiple protocols because it didn't initially. At which point, as soon as Cisco added that additional functionality, which wasn't part of the open standard, it became a proprietary protocol. Both ends of the link, again, must be Cisco devices to use Cisco HDLC, and Cisco HDLC is the default encapsulation on Cisco routers, so right out of the box, that's what they're going to try to do. If you need to set them up for PPP, you're going to have to configure that, but if you're trying to do HDLC, that should be the standard as they come.